So let's get started. It looks like it's 2 minutes early, so I'll try to finish 2 minutes late. I mean 2 minutes early as well. I'll finish 2 minutes early as well. The first point I want to talk about is this SSH business, which is where you can work outside of campus or outside of the labs and connect to the lab machines and do your work there. And I recommend that. It's very convenient, and it's good to learn that whole process as well. But it's a little tricky. So some people are having problems. They cannot log in. So I added this this explanation about what to do if you're having trouble with that. And I also sent out an email with instructions on what to do. Now basically, the passwords are a bit weak when the account gets created for you, and that's why we want you to change your passwords immediately so that they become a strong password. And but just to guard against attacks where people are trying to get into your account, that we have a very strict policy about the number of times you can try a bad username and password combination. So I believe, I'm not the one that's sort of managing that, but I believe the number of failed attempts is set at 3. So if you have 3 failed attempts, you will be blocked. And that means your IP address is blocked. So if you're at home and typically you're at home using a router, maybe you're on your wireless home network, and that wireless network is a private network, but your router is on the public internet. So it's public facing and has what's called an IP address, which is a number that identifies your computer from all the other computers that are on the internet. Not your computer, but your router rather. That number, the number of your router, is the number that was added by JBH3-1 as an IP address to block. So if you try to connect from your home network with a blocked IP address, then you'll simply get, you won't even be able to type in your username and password anymore. You'll just have a connection refused by the remote system, some kind of message like that, depending on the tool that you're using to connect with. So if you're at home and there's been some confusion actually about what username and password combination to use when you're outside the lab. The username passwords that I emailed to everybody, that is not to connect to JBH3-1. That's specifically to use when you're running subversion commands. That's that command svn, which I will illustrate today. So if you had tried to log into JBH3-1 using your subversion username and password, that will count as a failed attempt. And if you had tried it 3 times, then you'd be permanently, well, temporarily blocked. So what you need to do is figure out what your IP address is, and you can do that by going to a website that reports it for you, such as this website. This is the IP address. You can see it's 4 digits. Actually, I said 5 digits, didn't I? I made a mistake there. 5-byte values. This is not correct. I better change that. This is, I just wrote this up this morning. And there we go, 4. Is that right? It's 4? 1, 2, 3, 4. That's it. And I can't even remember that. All right, so this is the IP address of this computer here. And there's lots of firewalls and what they call packet filtering, so information set from one system to another on the internet is controlled. I don't have to answer that. All right, it's 4. So that's it. Any questions about connecting from home? So here's a terminal window. And you know, from OS 10, you can use that ifconfig command, and that shows information about your network. This is called the MAC address, which is a number that's coded into your network interface, into the hardware, although it can be changed by the operating system. And some other interesting values in there. This is called the Loopback Interface, and this is one of the, you have different interfaces to the network. So I have wireless interface, and I have a wired interface. So I could plug in a network cable and communicate through that. So there's different hardware on my machine to handle those different connections to the internet. And this is, let me just check something. Yeah, that's it. So this looks like, this is my IP address right there, right? That's what we looked at, 234.14. So you can get that on Linux and Mac. It's ifconfig, that's interface configuration. But on Windows, it's IP config, so it gives you the same thing. They just use a different name. I don't know why, but that's in fact what they do. Actually, it looks like a command here as well. All right. And let's go back to the schedule of assignments and talk about what it is we need to do this week. Basically, what we want to do this week is go through Lab 2 and learn about input and output and compiling programs and how to do that over the network and how to interact with a source code control system called Subversion. So here's the Lab 2. And in this lab, we're going to learn about version control systems, how to use them, how to use Subversion specifically, and then learn a little bit about the C++ language and about languages in general and computer programs in general. And for all computer programs, they have the concept of an input and output stream. And so we're going to practice reading from the input stream and writing to the output stream. So you can think about a stream of numbers, a stream of data. So when you have a running program, there is an incoming stream of data, which is simply a sequence of numbers, a sequence of byte values, and your program is responsible to remove data from that stream and process the data. And so if the stream could be empty, so your program can block on what's called a read, and would just wait until some more data becomes available. Then there's an outgoing stream, and that's where you send data out. And where does it go to? Well, that's configurable. So you can direct your output to a file, so it's just dumped into a file. You can direct your output to the display, so that to a console window, so that you see the data that's being written to the stream is interpreted as character data and it's displayed as characters on the screen. So there's different kinds of destinations for an output stream, and also the same for an input stream. There's different sources of the input stream. So when your program goes to process data coming in through the input stream, that input stream could be the keyboard, or it could be the contents of a file. Those are the two general places where we come from, but there are other sources as well, I believe. And like for instance, a network interface, an incoming stream could come from data coming over the internet, for instance. That's another possible input stream. So we're going to work with that. And what I'm going to do, as you know, I'll talk about the concepts and try to give explanation. But while I'm going to do that, well, I'm just going to do the lab. So I'm going to show you what you need to do to complete the lab. And then I'll talk about what's going on. That's my plan for today. All right, so I'm going to pretend like I'm at home and log in remotely to one of the computers in the lab and start working on the assignment. Now on OS 10 or Linux, you're going to use the command line with this command called SSH. On Windows, you'll use a different procedure. You'll use something like a graphical tool. PuTTY is the one that I use. It's free and fairly easy to use. I think I have a link to it somewhere up here.
Yeah, you have it in the SSH page.
I have it in the SSH page. Okay, so I'm not going to show that, but that's what you would need to do. All right. Let's do this. I need to log into, let me get to the SSH page. I need to go there to get that host name. Here it is right there. And here's the command that I would use without the name Alice, actually. I'll just copy this host name. This is a fully qualified host name. You know, this is the host. This is the name of the local name of the machine, and this adds extra information. This is like the street address of your house. This is the name of the city. This is the name of the state, and there's the country. It's kind of like that. It's a hierarchical sequence of you know, locations. So let's go back to here, and I'm going to do it like this. Instead of using that @ you know, I could do SSH Turner @ JBH3-1, but I could also specify my username with this this flag -L. All right. You notice I'm typing my password, but I didn't see any asterisks. It's like extra secure, right? So if someone was looking over your shoulder, they wouldn't be able to count the number of characters that you're typing. So don't let that fool you. When you're typing in that situation, the program is reading your key presses. Now we're on JBH3-1, and actually I don't know how to. Maybe I type in host name. There it is. Yeah, just use the host name command. I can see where I am, and we cannot work on here because this is just a gateway machine. We need to log into a computer that's in the lab. For instance, number 8. Or I'll change it. I'll call it number 9. I've never logged into this computer before, or the operating system has been reinstalled and new security credentials generated for it since I last connected to it. So that's another possibility. And so the system has never seen the security credentials being presented right now. And so it wants to know what to do. And I'm going to say trust it. All right, let's try that host name again. Well, like, see that this command history, this is a different command. This is a command history in the lab machines, not the command history on JBH3-1. So I don't have host name in there. And there it is. So we're on JB359-9. We can see if anyone else is logged in. If I go users, I can see the other users. If there's someone up in the lab who's using the machine, I'll see their username. If someone in this room logs into that machine, we'll see their username. If anyone wants to try that, try to log into this machine. We'll see your username pop up there. So, nobody yet? Let's now we have access to this program. We also have access to the compiler, so we can do our work now. Let's go back to this Lab 2 Subversion. And let's go ahead and we're going to check out, we need a directory called CSE201. And we're going to make this directory under the home directory. So if we just enter CD by itself, that means go to my home folder. That works on Windows, it works on Linux, Mac, it's the same thing. But we're on Linux. Or we're working on Linux right now. We're not working on Macintosh. That's Macintosh just running the console program. We're going to use the text editor and the compiler on a lab machine that we're logged into, which is a Linux system. And I think I already created that folder. There it is. And I'm just going to delete that folder, just go through the whole process again of creating it. Be careful with this command. See that -RF. R means recursive, it means delete what I'm naming and everything under it. And F means don't ask for confirmation, force it, just do it. So if you do this in the wrong point, you're going to lose your work, or you're going to delete configuration files from your home directory. So this is considered a dangerous command in that form. So once again, CD brings you to your home directory. PWD shows me where I am. You'll have a different location. Let's make a directory called CSE201. And now I'm going to check out my, my repository. And this is the command that I'm going to use right here. Except your username needs to be, that string needs to be replaced with your real username. And your username will look something like that. It will be first name underscore last name. Oh, maybe not. I don't remember. Whatever I emailed you, I don't remember what it is, how we created those usernames. Maybe it's a little different than that. And oh, I remember now. I didn't do this right. Yeah, that's what last quarter I used first name, last name. This quarter I'm using what your email address looks like. Pulled out your email address. So this is one of my email addresses here. Normally, I cached my password, so that's why it didn't ask me for my password. But it's going to ask you for your subversion password. That is the password. It's going to ask you for your subversion username and password. And that's the username and password that I emailed to you. So this is the point where you use that username and password. But if you agree to have your password cached, then you'll only need to enter your password once for the repository, not for logging in to JBH3-1 and then logging into one of the lab machines. In that case, you'll always need to use your password. But for interacting with a repository, you can issue your username and password once, tell the system to cache the information, and then you won't need to bother with entering that data again. And you can see the list. It shows you what happened here. You know, this folder got a subfolder called Lab021. It got a file in that subfolder called main.cpp, and it also created another subfolder, lab02_2. Let's go into I'm going to cd, so I'm changing my location using the cd command. Change directory. And I have a path name here, and this is a path delimiter. So the first element is the name of the folder that's under me. This is a child folder, a child of my current folder location. This is a child of my current folder location, and then there's the path delimiter /, and then there's the another folder. So it's a folder within a folder. And I know where I am, but just in case, just to check, I can do print working directory. And there it is. So I'm in my home directory. I know that my home directory is here. And that's a path to my home directory. Then there's the path delimiter / it's a folder we just created. And then there's a folder in there that I checked out from the repository. And here's the file main.cpp. We can open that up in Nano. And this is a simple program to says bye. Control X exits. And if I change this to bye to, and I don't want to just Control X to exit, I want to write out. So that's Control O. And it's asking for verification. Is this the file you want to write to? Yes. And then Control X. We just modified that file. Now let's compile it. There's no messages. That means it was a success. And you'll see here, there's a file a.out that got created. And that's an executable. I can use the long form of the ls command and look at these, what do they call them, permission flags. So the first three, well, forget about this dash, that's something else, but these are the three permission settings for the owner of the file, and the owner of the file is Turner. The next three characters are the permission settings for the group that's associated with the file, and that group is called users. And then the last three are permissions for all users that are logged into the system. Question?
What was the second step after you control O in the
So there's a Control O to write out. That's to save your changes. And then it's Control X to exit. That's all I ever use in Nano. There are other commands, you know, read file, previous page, cut text, uncut text. So there's other commands that you can learn. I don't usually use in Nano. I use a VI. But Nano is a lot easier to use, and for the purposes of this class, you only need those two commands. But if you want to learn the other commands, that will help you work faster. So I've got read permissions on a.out. I've got write permissions. That means I can modify the file. And I have execute permissions. That means the file can be executed. Look at main.cpp. You'll see that the execute bit, they call it the bit. It's either on or off. The execute bit is off. That means I cannot issue main.cpp from the command line like that. I can't tell the operating system to, hey, run that file. Well, it's not an executable. It's just a text. It's a file that contains character data. It's not a file that contains machine instructions. It's not a file that contains executable, loadable, and executable code. And of course, if I set the execute bit, I could set the execute bit and try to run it, but it's not gonna run correctly. It'll violate some constraint that the operating system puts. May be interpreted as containing illegal characters. Illegal instructions. So I run a.out. It says by 2. That's it. Now, I didn't show the whole process of what to do in here. I did this in lab, I believe. Last time I showed the lab students how to do this. Initially, my repository was empty. And I was able to show how, in lab, how this command, when we execute this command, this whole command, I was able to show how executing this whole command causes a checkout of an empty repository, which is what we want, because you're not just getting nothingness, you're getting a configuration file that's used to interact with the repository. So this is a necessary first step. Then after you do this checkout command, then you make these folders and then issue these add commands here to add the folders to the repository or to schedule them to be added. So when you start this exercise, I recommend that you follow this sequence. And if you have trouble interacting with a repository, then please talk to me as soon as possible, or talk to Jaron Willis. He's the TA for the class. He's also has a lot of experience doing this for this class. So it can be a little messy in the beginning of the course to learn how to use a repository, but once you learn it, then it's pretty effortless. All right, let's do exercise 1, personalized hello program. The program will prompt the user for their name and then display the sentence, hello, name, nice to meet you. So let's go ahead and do that. So it's going to say hello. Let's see, it's going to prompt the user for the name. Let's do that. I'm going to edit the file. Whoops, not in VI here. Ah. You know what? Let's see. How do I undo? Control U? No. My delete key does not work correctly. Oh, there it goes. Not really. So, what is your name? And I'll put a space here. So when they type their name, it doesn't, there's a little room. So what is your name? And then when we type that in, we're going to read the name in. So we're going to do something like this. We're going to do string name. Well, what we need to do is we need to have a container for the name. So we'll declare it here. So there's a variable name, which is of type string. So if you have a book and you're reading about this, this is a variable declaration. We have the variable name here. Follows the type of data that's stored in the variable. So a variable called name. and it's going to store data of type string. And then there's this command, cin, that's the standard input stream, and the cout, that's the standard output stream. When you have the standard output stream, you have this double less than symbol. That means we want to write something into it. So what we write into it follows the symbol. Here we want to read from the standard input stream, so we have a double arrow symbol but going in the other direction, and we want to read it into name. So this command, this statement right here, it causes the program to pause and waits for the user to enter in a string on the console, on the keypad. And then let's print it out. Let's see, something like this. Hello. We're going to print hello with a space. And then we're going to print the name. And then we're going to print, oops. Then we're going to print nice to meet you. And then I'm going to print a new line. Make the same mistake there. An endl, it's an end line. I'm going to print a new line just to make it clean. I think this is. I think this will work. The only thing else that I might want to be concerned with is that this data type string is. The compiler may not have a definition for that data type. And this is kind of compiler dependent. So although the compiler might find it on my system, it might not find it on your system. So I'm going to include what's called a header file that contains the declaration of the string data type. Once again, this particular header file is needed for some compilers and not for others, because in some compilers this string definition is included through the IOStream header file, and for other compiler environments their IOStream header does not result in the eventual inclusion of the string header. So there's some differences there between compilers. I'm going to Control O to write, and I'm going to Control X. And then let's see if it compiles. Okay, now that should not happen with you because you'll probably get some mistake in there. And so let's be more realistic about this. Let's suppose you forgot something. Maybe put an X here. Right? So this symbol is not understood by the compiler. X using is not a symbol that the compiler knows what to do with. Let's see what happens in that situation. Sorry, this should be Control O. Control O, Control X. All right, what happens when we get a bad symbol in the file? Well, we get something you can't really read. That's one of the challenges when you're doing this sort of thing, is that the compiler doesn't really know how to talk to you in a friendly, easygoing way. It just dumps out all this technical stuff. And what I do, which is what I think everybody does, rather than reading every single character here, that look for clues about what's going on. So let's go back to the beginning. This is the command. And this is the output of the C++ command when we pass it main.cpp as an argument. So let's start at the beginning. The first character is an M. Let's start there. That's where to start. So I've got main.cpp. Oh, that's just telling me the file name. And then there's a colon. Oh, so they're going to give me information about main.cpp. What is that information? Well, there's a 4, and then there's a colon, then there's a 1, and then there's a colon. And I want to tell you, because you could probably figure this out on your own, but just to save you that time spent, that this is the location of where the compiler says it can't, it's finding a mistake. It's the 4th line, the first column. The 4:1 means 4th line, first column. So in main.cpp, in the 4th line, first column, there's a character, the beginning of a character sequence that the compiler is saying is a problem. And then saying error here. Error, X using does not name a type. So you don't have to read anything else. I mean, at this point, we have the information we need. So all this other stuff is kind of error messages that were that come from other problems in the program that are a result of the first error. So we can safely ignore that and just fix what we identify as the error right here. The first error. So when you look at these compilation problems, the error reporting on compilation problem, fix the first problem that's reported, because all the other problems are probably a consequence of your first error. Let's go back in here and fix this. Let's see, the delete key, is that going to mess me up? There we go. Looks good. So Control O to write it out. Control X to exit. That's a lot of confusing stuff on the screen. I'm going to type in clear to clear it out. LS, yep, that's our situation here. And we're going to compile the main program again. Now let's run it. What is your name? Alice. There it goes. That's the first exercise. Now the next step here is to transfer the file, the source code, to the repository. And before I do that, I want to show you how you can check to see your work that you're transferring into the repository. You use the Svn command to upload your work, and you can also use the Svn command to download your work as well, to synchronize with what's in the repository. That's what Jaron and I are going to do. You're going to be committing your work, writing it into the repository. We're going to be checking it out. We're going to read your source code. We're going to compile it. We're going to run it, verify that it works. We're going to give you feedback. When it doesn't work right, we're going to give you feedback. Even if it works correctly, your coding style has to be clean. So we're going to give you feedback on that. All right, so this is as you can see here, this is a web address. And we can go there and look at it. Whoops, paste and go. That's not where I wanted to go. This should be changed. There we go. The site security certificate is not trusted. I talked about this last time, so I don't want to kind of repeat it again unless you want me to. But you know, there is a security certificate being presented by the server, but it's not signed by trusted authority. And it costs money to have your security certificate signed by trusted authority. So I'm going to proceed anyway. This is the username and password, not for JBH3-1, but for the repository. This is the username and password that I sent to you. These are the two folders that I created in the last lab that I managed. And this is the state of the program. This is what we checked out. When I sat down, I did a checkout, SVN checkout. This is what was in the repository, and then we modified this. And so what we're looking at is the unmodified original file. But we have modified the file. So I'm going to CD, and I'm going to go up to here. I'm going to go up to that CSE201 folder. That's the root of my working copy. So when you work on files as part of a software development project, you have this thing called a working copy. So you've got the repository where all the source code is stored. All the team members are accessing that repository in a central location, and you have what's called a working copy. So I recommend to you, although you can do it differently, I recommend to you to interact with the repository from the root folder of your working copy, and that's CSE201. So I didn't create any new folders. I didn't create any new files. All I did was compile a file. I modified a main.cpp. So if I do Svn Commit -m, this is the command to transfer the data from the working copy to the remote repository. Before I execute the command, I want to show you something here. It's got the revision number here. This is the second revision. So, you know, when you first check out your empty repository, it's revision 0. And then when so I did 2 commits. I committed revision 1 and I committed revision 2. So we're working against revision 2. And when I complete this commit here, we will then increment. The revision number will go to 3. That'll be so at every commit every successful commit increments the revision number. Now the commit command, SVN is the outer command, and SVN supports a number of inner commands. I don't know, that's not exactly the terminology people use, but it's SVN is the program that you're running, and you want SVN to perform a commit. So you can think of it as a command within a command. And commit needs some information. It's got optional information, it's got required information. Optional information include the thing you want to commit, but I'm omitting that. So it's going to say, oh, you want to commit the current folder and, you know, all of its contents. But one thing that's required by commit is a message. So this -m is a message, and you can put a message in between those quotes. So we completed problem 1. But now this message is optional for us, for this course. But the command requires it because it's important. When you're actually working in a team and working on software development, you want to label your commits so that the other developers and yourself can, when you go back into the history of your project, you can see what happened when. So a message is important for that purpose. But for this class, I'm going to be not committing messages. But once again, it's required by the commands. They're going to pass in an empty string. So it's a string that has no characters. So starting delimiter, ending delimiter. The delimiter for a string is a quote. Sending. It shows you what it's sending. It only sent main.cpp. So I come to here. It says revision 2. But if I refresh the web page, it'll say revision 3. There it is. And now the revision, these are, the revision number is not the number of the file or folder revision. It's the entire project. Entire project has a revision number. So you can think of these revision numbers. You can think of this as a sequence of snapshots of your entire project, and those things are numbered. We look into main.cpp, we'll see that now it's different. It has the code that we want. This is lab 022, that folder. This is for the second problem. Let's do the second problem. Oh, we're here already. So the second problem is to draw a triangle. This is what the output should look like. And then go ahead and, and commit your work. Let's take a look at that. So going into the second folder, there's nothing in there. It's hard to remember all the details of the C++ program or any program in any language. So what people do is start from an existing file. So I'm going to start with the solution that we have for exercise 1. So look at how I do the copy. That's the command. This works on Linux. This works on Windows. We're working in a terminal window. We're logged in remotely, so we have to use the command line. Of course, if you're working locally, you can use your graphical user interface. You can copy and paste using, your graphical view of the file system, with folders and files. But we don't have that in the environment that we're currently working in. So we're using a command line copy command. ... means go up to the parent folder. So this ... it names the parent folder of my current folder location. And my current location is lab 022. So I want to go up to the parent of lab 022. And that's a CSE201. And then from CSE201, there's two folders. The folder I'm in, lab 022, and then there's the other folder, lab 021. And that's the folder that's got the main.cpp file that we created. So once we go up to the parent, and then we start to go down from the parent into the sibling folder, and then reach into it and get the file, main.cpp, that's in there, and then space and dot. That's not a mistake, that's a dot. That means I got to give the source, this is the source of the copy command, the source. What does I want to copy? which is a named individual file. And this is the destination for the copy, which is dot. What is dot? Current directory. There we go. Great. Everyone's got that. That's good. So there's the copy. And let's take a look at it. There it is, in fact. That's the copy. Now we're going to write a triangle. And this is actually easier than this is crazy. This nano, you'll have to live with this. This is pretty crazy. Another way to do this, of course, you could write your code locally and just paste it into nano and do it that way. Or could you use a different editor like VI? If you want to be a system administrator, maybe you should start learning VI. Actually, I'm going to do that. Save changes. No. Okay. I'll show you VI here. VI is a very popular, it's an antique though. It's really an antique VI. It's got very strange key combinations to do different operations. And but it's everywhere, and all the old timers are using it. Not all of them, but system administrators, old time system administrators, they all know how to use VI. So you see, it's very common, and it might be useful to learn. It's also very fast. The people that they have these contests where they compete over which who can write code faster using different text editors, and the VI people always win. Well, that's what I heard. So I'm not going to say that as an authority, but I have heard that the VI competitors are the ones that win, just simply because that you can issue less keystrokes to do common operations. So let's go through this. This is called insert mode. So I've pressed I to go into insert mode. Press escape to leave insert mode. I to go into insert mode. You can see the indication of your mode here. There's only two modes that I use, like the insert mode and then the command mode. There's another mode, I don't remember what it is, but I'm not a VI expert, but I do use it. But not to write program. I don't use VI to do computer programming. I use it for system administration. For programming, I use it like an IDE, like Visual Studio, or Eclipse, or Xcode, some integrated development environment that's much better to use, or an editor like Notepad++. I use that, and so on. So anyway, we've got VI. We're in a console window. Let's go ahead and use VI at this point, and let's put a star here, and let's go ahead and delete these. Now, one way to do a new line, if you don't do a new line, you won't go to the next line in the console output. You can use endl, but the alternative to this endl is to put in a \n. I can put a space there too, doesn't matter. \n, that backslash is a control. This starts what's called a control sequence. So it tells whatever system is reading the characters at this point. We say, hey, system, which is the compiler, we don't want you to print a slash. We want you to print a special character that I can't type into the string. And so the compiler says, oh, slash, okay, special character sequence. And, oh, you want a new line character. Oh, that's ASCII 10 or, UTF-810 as well. But depends on the character set you're in. This will be interpreted, and some data value be generated. Some data value that you wouldn't normally put in here directly. So you use a character a special sequence of characters to insert the data. So let's let's go ahead and this is going to be some kind of a branching thing, right? So we're going to have a star at the top, and we're going to have like a pyramid, something like that. Oh, by the way, you see this. I go into insert mode, leave insert mode with escape. I don't know if they covered VI in the Linux workshop. Did they cover VI? They did? A little bit, right? A little bit. I'll just talk about it as I'm doing it. And then colon, that brings up the command prompt. And then I can, W is write. That's like that control O to write a nano. And it gives you the information. Main.cpp is written. And then colon Q, that's to quit. But the fast way to do it is just I want to write and quit. So you can do it together like that. Let's compile. Let's run it. Yeah, it looks good. But it's not enough. We want more. So I'll go into insert mode here. And so I'm just going to, you can do it visually actually, right? And I'm just going to do it have like a line at a time here. I'm getting the hang of it. I only need to, it's a little algorithm. Just to write the code, it's an algorithm. Of course, you could use a loop and a counter, and you could write this differently. You could do it, you could automate. The very algorithm I'm following mentally, you could code it up and generate the asterisk that way. But that would be using features that we don't know about yet. Yeah, I can do it faster now. I know that I'll need 2 spaces there and 1 space everywhere else. There, I got the algorithm figured out. You know, that's what programming and software development is all about, is figuring out algorithms. What is the sequence of commands? What is the sequence of operations? And how do I do things differently based on different scenarios, different conditions? And just coding it up. Basically figuring out these mechanical information processing tasks and translating that into computer instructions. Let's see how that works. See, if I do this, this will throw you off, right? I didn't compile the program. I changed the source code, but we didn't compile the program. So the executable hasn't changed. We need to compile the program and now run the program again. There it is. Oh, I think the problem has a base on the triangle, right? We need a base there. So let's get that base in there. How did I do it like this? Oh, 1 too many spaces. Okay. All right. That looks good. Once again, you know, it looks easy for me, but you know, you need to get ready for you know, things like this. Like you're gonna have mistakes. So it's gonna look like that. Okay, that's, you know, when I do it, it's just gonna come out right usually. So I mean, at this easy level. So look, once again, there's an error, and we go to the first piece of information in the error output. We see that there's a line number and a column number. Error stray / in program. So you can use that as as a clue to fix the problem and get a compilation. Okay, that looks good. Let's commit the work. Right now, there's nothing there. If I go to this folder in the repository, I see that there is, in fact, nothing, no file there. So let's commit that file. You'll see the revision number will go to 4. That's the revision number that numbers the entire snapshot of the project, not just the file. Let's go ahead and commit that. One rule I want you to follow is work at the top level. On the other hand, when you do a commit, but when you're at this lower level, you can do svn add main.cpp. You need to tell Subversion that you want main in there. It hasn't been transferred to the server. It's just marked as being an object that you want to go into the repository. So you're placing it under revision control with that command. But we do not want to add a.out. That's something we don't want. And so I'm going to go up a level, see that I'm in my root of the working folder, working copy, and issue the Svn Commit. Look at I'm going through the command history. You can do this. I mean, this is slower than me typing it in there, but just to show you, you can use up arrow, down arrow to scroll through this command history, reissue commands. There it is. It's adding that. There's the file. There it is. We're doing software development here. Okay. Got a triangle program. That's it. Once you got that data committed in here, some additional information about using Subversion. Once you get that triangle in there and the hello program in there, you're done lab 2. And Jaron and I will check out your work after the deadline, and then we will grade your lab submission. Any questions? That's it. We'll see you later.